Hello everyone, I am Mohan Naik, Assistant Professor, Triple Department, Marri Laxman Reddy Institute of Technology and Management. And today I am going to discuss the topic is transformers. So overview of the transformer. So in this class we are going to discuss what is the need of the transformer and what is the transformer and what is the working principle and construction of the transformer and EMF equation of the transformer. First we are going to discuss about the transformer. So transformer is a static device. Transformer is a static device, and transformer transfer the electrical energy from one circuit to another circuit without changing any power and frequency and power. So without changing any power and frequency, transformer can transfer the electrical energy from one circuit to another circuit. So that is the main function of the transformer. So what is the need of the transformer? Why we use the transformer? Generally, electrical energy is generated at far away from the load centers. For example, you can take any power plant which is located far away from the load center. For example, NTPC Ramagundam or KTPS, Kottagudem Thermal Power Station. So all these power plants are located far away, hundreds of kilometers away from the load centers. So in order to transfer the electrical energy from generating station to the load centers, we need to transmit the electrical power. We need a transmission of electrical power. So in this transmission of electrical power, we are getting a transmission line losses. So when we get the losses, then the efficiency of the power will be decreases. Then we use a device, the transformer, which can step up the power, step up the voltage at each and every stage. Then we can utilize the maximum power. So this is the main application of the transformer. Now we are going to discuss about the transformer. Generally, transformer is a static device. Already I told transformer is a static device. Why it is static device? Static means there is no rotating part in the transformer. No rotating parts in transformer. There is no rotating part in the transformer. So if we consider the machine is consisting of a rotor is the rotating part. So it is a dynamic device. So transformer is a static device. The electrical circuit of the transformer can design like this. Transformer is consisting of two windings. Called primary winding and secondary winding. And primary number of turns in the transformer is called N1 number of turns, and secondary number of turns is called N2 number of turns. And supply voltage is V1, primary supply voltage, that is the input voltage, and current I1. Secondary voltage is V2 and current is I2. This is the load current. The winding which is connected to the supply called primary winding. The winding which is connected to the load is called as secondary winding. And transformer is transfer the energy from one circuit to another circuit. It may be a step up the voltage or step down the voltage. Transformer may step up or step down the voltage levels. When it is step up, when the transformer winding coils are primary number of coils N1 is less than N2, number of turns in the primary are less than the number of turns in the secondary. If that means more number of turns in the secondary, then called as step up transformer. Step up transformer. If the number of turns in the primary is more than number of turns in the secondary, then this type of transformer is called as a step down transformer. So in this manner, transformer can transfer the energy in two modes. One is step up or step down the voltage level. The number based on the number of turns in the transformer, based on the number of turns in the transformer winding. Next, we are going to construction of transformer. Construction of single phase transformer. Construction point of view, transformer is consisting of two main parts. One is transformer core, another one is transformer winding. Based in overall construction point of view, transformer is consisting of two main parts. One is transformer core and another one is transformer winding. Construction point of view, transformer core and second one is transformer winding. Other than this, we have another auxiliary parts are there. So these are the main parts of the transformer. First, we discuss about the transformer core. Transformer core. A transformer core is made up of silica steel material. Transformer core is made up of silica steel material. Silica steel is the property of silica steel is good permeability. That means permitting ability is good for silica steel material, and it consisting of it is a ferromagnetic material. Ferromagnetic material. It is a ferromagnetic material. A transformer core, a steel material, for a steel material, a 4% of silica material is added to the steel, then it will become silica steel material. After that, we are doing the CRGO process, that is then it is become CRGO, silica steel material. Silica steel material. What is the meaning of CRGO? Cold rolled grain orientation process. So a core material of the transformer is CRGO silica steel material. CRGO silica steel material. So based on the types of the core, transformer magnetic core, the transformer cores are two types based on types of magnetic core. We have two types. One is a core type transformer, and another one is a shell type transformer. One is core type magnetic core and another one is a shell type magnetic core transformer. So what is the difference between core type magnetic core transformer and shell type transformer? So first one is, the transformer is consisting of two yokes and two limbs. Core type transformer is consisting of two yokes and two limbs. Yoke means the horizontal part of the transformer core. This is the transformer core. So the horizontal parts of the transformer core is called as yoke, and the vertical parts called limb. So in this core we have two yokes and two limbs. In shell type transformer, the arrangement of shell type transformer is this one. In this shell type transformer, we have two yokes and three limbs. Limb is a vertical part. 1, 2, 3. Three limbs. So in core type transformer, two yokes and two limbs. In shell type transformer, two yokes and three limbs. And arrangement of winding on a core in core type transformer is on outer limbs. Arrangement of winding in shell type transformer is in inner limb. That means the core is in core type transformer, the winding is the core is surrounded by the winding in core type. In shell type, the winding is surrounded by the core, reverse way. So when we arrange the windings on the outer limbs, we have one drawback, that is a leakage of flux. That is, the leakage of flux is more. Flux leakage is more in core type transformer. In core type, we arrange the winding on the center limb, so there is a less leakage flux in case of shell type transformer. If the winding is arranged on the outer limbs, then there is no mechanical protection for the windings. In a shell type transformer. So less mechanical protection, no mechanical protection. Protection for winding. In this case, good mechanical protection. Why? Because we are arranging the winding on the center limb, so good mechanical protection maybe exists. Good mechanical protection. So in core type transformer, arrangement of winding is interleaved type. Interleaved type of winding is arranged in the core type transformer. And sandwich type winding arrangement in case of shell type transformer. And core type transformer, the number of the efficiency of core type transformer is less compared to shell type transformer. Efficiency is more in case of shell type transformer. So these are the difference between the core type and shell type transformer. In core type transformer, the arrangement of winding is interleaved winding, and the shell type transformer, the arrangement of winding is sandwich type winding. And core type transformer, we have two limbs and two yokes. Shell type transformer, we have two yokes and three limbs. And when we arrange the interleaved winding to reduce the losses, interleaved winding is arrangement is to reduce the losses. Those losses are hysteresis and eddy current losses. Hysteresis and eddy current losses. And this arrangement of winding in case of core type is series magnetic path. Series magnetic path. In case of shell type, it is a parallel magnetic path. In shell type, parallel magnetic path. So thank you.